Hi, this is me, Mr. Mays, and I'm super excited to be speaking with you across the sort of digital universe. We're going to be looking today at the Unit 3 Pro Tips video. I'm going to keep this one relatively short. It's going to be chock full of all the important things that you need to feel comfortable for the Unit 3 exam. I'm going to give you a couple of tips that you might want to be aware of, but also I want to start by saying this. Make sure you go through and watch the 54-minute video on conditional probability, that you watch the 34-minute video or 32-minute video, I can't remember, about general probability. Make sure you go through all three slideshows, 3.1, 3.2, and 3.3. All of that can be found on Canvas. And then make sure you've gone through and worked hard on the Unit 3 review guide with the answers. And make sure you've reached out to me on Remind if you have questions about any of those problems so I can solve them for you and give you more in-depth information. Okay, I will start by saying this exam is not terribly difficult. I throw a couple of challenge problems in there, but the difficulty from this exam comes from the material as it sits. So if you felt solid or feel solid on the review guide, you're gonna feel pretty solid on this exam. I throw most of my tricks into the review guide. So if you know those inside out and backwards and you know the way to get to answers through those, you are set. Now, before I go into anything else, I wanna talk about one tip or trick that is going to do you a lot of good, okay? I want you to notice that this is almost like a Christmas-themed version of rolling two dice, right? So this is the sample space of rolling two dice. And the first thing I want you to notice is that if you take a look here and we look at the longest diagonal, you will note that these all equal to 7, right? 7, 7, 7, 7, 7, 7. So if you add those all up together, you'll note that there are 6 different ways to roll a 7. And I want you to note that that pattern holds true for all of rolling two dice. And this is important because there are a lot of questions on the AP exam that ask you to think about all of the possibilities of rolling two dice without showing you this sample space. And I will warn you that there is at least one problem on my exam where you have to run through a probability like this. So the thing I want you to notice is that there is one fewer number of ways to roll two dice to reach a 7 than the number 7. So there are 6 ways to roll a 7. You will note that to roll a 6, there are 5 ways. 1, 2, 3, 4, and 5. You will note that to get a 5, there are 4 ways. 1, 2, 3, 4, and so on. 3 ways to get a 4, 2 ways to get a 3, and only 1 way to get a 2. You will notice that once we get to 8, that goes down again. So instead of 6 ways to get a 7, we have 5 ways to get an 8. 1, 2, 3, 4, 5, and so on and so forth. But I just want you to be aware of this, and I want you to notice that there are 36 total ways, right, going in all directions of rolling two dice. Okay, so for example, if I were to give you a problem where I were like, what are the odds of rolling a 3 given that you have rolled a 5 or lower, right? What I would do is I would look at 5 or lower, and I would remember, without even looking at this chart, I would remember that a 5 means 4, 1, 2, 3, 4. A 4 means 3 options, so 3 plus 4 is 7. And then a 3 means 2 options, so 7 plus 2 is 9. And then a 1 is 1 option, so that is 10 total ways to roll a 5 or lower. So that would be my sample space over 10. And then I would remember, of course, that I said my odds of getting a 3 exactly. And there are 2 ways to get a 3, so a 2 out of 10 or a 1 out of 5 chance. Okay, that should make sense. I want you to understand how you can do that without even looking at a table like this. You can run those probabilities. So starting with a 7 or lower, each one of those odds is 1 less than the number represented, right? Odds of rolling a 7 with 2 die is 6. 6 is 5, 5 is 4, 4 is 3, 3 is 2, 2 is 1. And there is no 1. Okay, that's my first tip / trick for you, something that'll help you and save you some time. Okay. Make a little line here and let's roll ever forward. Okay, make sure you do the multiple choice problems on the review guide. I really pushed this. This is an overall trick. It's not a trick. It's not a specific trick, but know those questions inside out and backwards and drill them, okay? The other thing I want to note about the multiple choice specifically is that you will notice the 2 main ways that you solve that are using trees right? Tree diagrams, and by doing your equations. And you should feel very capable of those equations. The two main equations that I give you already on the exam, you probably already are comfortable with, right? They are the odds, the probability of A given B, or B given A, however you want to think about that. That's one of the equations that I give you. All right, and as you know, the probability of A given B is always going to be equal to probability of A and B divided by, and this should make good sense, the probability of B in this case, right? Why? Because we're saying, what are the odds that A is true given that B is true? Your given will always be the denominator, and then your numerator has to be representative of the probability of A, which is the thing you're looking for, but it has to be given B. Otherwise, you'll get a value more than 1, and we all know the realities of that. You cannot get a probability where the value is greater than 1. Okay, that is going to be on the quiz for you to refer to, but you need to know what that is. You'll also get the equation of the probability of A union B equaling probability of A plus probability of B minus probability of A intersection B. That is going to be on the exam for you. You should know, though, that for a disjoint or mutually exclusive set of events, this guy goes away, and we only have probability of A plus probability of B. You should know that, right? That in a sample space where two events are mutually exclusive, you just add the probabilities of the two events together, and that is the union of those events. Further, another equation that you should have sitting in your repertoire is the probability of A intersection B. You should know that if they are dependent, there isn't really an equation for this. You either have to check the table, if I give you a table, right? Or it will be given to you as a percentage or a value, and you have to work with it accordingly. On the other hand, if it is independent, the probability of A intersection B, if it's independent, then you should know that the reality is it's the probability of A times the probability of B. Further, you should know that this is one of your tests for independence, that your tests for independence are either going to be you doing this or going to be you saying, hey, the probability of A given B is equal to the probability of A on its own. Or the other way I've written this before is the probability of B given A is equal to the probability of B. This whole thing, these are the same, just interchanged for which one is, the first, there's my low battery, for which one is the first event and which one is the second. But these rules are only true for independent events, and you need to know that, and you need to be able to apply that, and you need to know how to test for independence and dependence. Okay, that should all feel fairly settled for you. Let's pick a new color. Let's go for blue. Huge point. I know you know this. Practice your two-way tables. Practice your two-way tables. Practice your intersections. Remember that your givens, whatever that given is, that's going to be your denominator. Oh, I almost wrote demominator, like a demon. Denominator is your given, right? So given that blank is true, you already should be looking at the total of the thing that's given, and that will be your denominator, right? On the other hand, if it's just a prob, if we're just looking at the probability of blank event, you're looking for the full total. And we've gone over these a lot, and you should see in the take a look at the conditional probability video, and we run through how to read some two-way tables. But make sure you're good on two-way tables. Those show up a fair bit in this exam. Further, and this should make sense too, know your trees. Know how to run a tree diagram. Tree diagram. Let me get rid of that diagram. Make sure you can read a tree diagram. Make sure you're comfortable with a tree diagram. Be aware that if there's an event, probability of A, and let's say probability of A has an X probability, remember that the probability of not A, and you should know this notation, that C means not, is going to be equal to 1 minus the probability of A. Know things like that, right? That the odds are always going to be blank minus blank, or whatever the situation is, right? So whatever the odds are of a particular thing occurring, 1 minus that particular thing occurring is going to be your situation there, unless otherwise stated by some condition. Okay, we're rolling on that. You should feel comfortable with tree diagrams. On the multiple choice, you will, for the most part, and I think I've already said this, but you will, for the most part, always be using a tree diagram or an equation to get your way through. Be comfortable with those. Probability of A union B equals probability of A plus probability of B minus probability of A intersection B. Remember that unless the question says it's independent, let me get rid of that, that's just me saying this. Remember that unless the question says it's independent, you can't calculate probability of A intersection B by multiplying A and probability of A and probability of B. Only if it's independent is that true. Otherwise, this must be given to you, or this might be what you're solving for, as was true in some of our multiple choice on the unit review, and you would plug in these values to solve. Be very comfortable with the different wordings for each one, right? What are the odds that either blank or blank is true? When you see either, when you see or, that's a union. When you see probability of a thing, that's probability of A or B. When you see probability of not that thing, it's probability of contra A, right? Or the contra of A, the opposite of A. Complement, we often call it. Same thing for probability of B. And then it's always like an and, right? What are the odds that blank and blank are true? That's that intersection. Oh my gosh, I had that Sabrina Carpenter song. So that's that Me Espresso. Okay, but it's not that. It's that intersection. Okay, so we've got all that. I've already said this, but I want to say it again. Watch the video notes, go through these slideshows, make sure it's all comfortable. Remember, as always, some things to keep in mind. Probability is always long-term. I really push this home, but if it says, if the odds of a thing happening mean that on the next flip, my odds are blind. It's like, no, it doesn't mean anything about the next flip. It means in the long term, something is likely to happen, okay? And remember that the law of large numbers, which you may have forgotten, but I don't want you to. I stood on a table for this, large numbers, means that as n, and n is always the number of trials. So as our value n, the number of trials goes up, our probability approaches the true probability proportion. So if I'm flipping a coin, heads or tails, as n goes up, the odds approach, right? The probability approaches 0.5 for either heads or for tails, right? 1 out of 2. As n goes up, and this is for a coin, right? As n goes up, our odds on a die approach. For any particular roll, our odds approaches 1 in 6, right? Because there are 6 die sides. So be aware of that that's what the law of large numbers always is stating, okay? Some other rules to remember that you may have forgotten or that may seem obvious, but that I want to just be on your radar so you can answer them quickly on an exam. Probability is always between 0 and 1. Right? A probability is always between 0 and 1. That should seem obvious, but you must know it inside out and backwards. You cannot have a value lower than 0. That is not possible. You cannot have a value higher than 1. No less than 0, no higher than 1 for probability. Second thing to be aware of for probability. Probability of an event is always equal to the probability, or I should say, is always equal to, here's the better way to state it, if I can get my eraser to roll with me, is always equal to 1 minus the probability of not that event, right? Because not that event is everything that doesn't represent that event. So if you subtract everything that isn't that event from the value of 1, you will get the probability of that event. That is always, always, always true. Know that in any phrasing and be able to choose it as an answer. And remember that mutually exclusive events, okay, so events where when one occurs, the other can never occur, right? Two events that literally are so dependent, they can never happen at the same time, okay? Remember that they have, if you say, what are the odds of blank or blank? For mutually exclusive events where or is used, right? Union, you just add probability of event 1, we'll call that A, plus probability of event 2, B. That's all you have to do, right? That's all you have to do. There's no intersection to subtract for mutually exclusive events. Okay, so I've given you some tips there. That'll show up, I guarantee you, on the multiple choice in some format. Know that, live that, believe that. Okay, now let's talk FRQs for a second. I'm going to let you know. The FRQs, I'm not going to give you an exact breakdown, but I will tell you. Trees will show up on the FRQs, either where you have to make a tree or where you have to fill in gaps on a tree, okay? So know how a tree is notated and functions, okay? You will definitely have word problem. I mean, that comes with the territory, right? You will have word problems, I should say. Word problem is singular, is funny. You will have at least one word problem. You will have to run probabilities from a two-way table. So similar to some multiple choice questions as well, right? But you'll have to run some probabilities on a two-way table. There's, in fact, I will spoil this. There's, in fact, one FRQ where the whole FRQ is like you run 3 different probabilities to show me that you know how to do like, you know, blank given blank or just blank overall or any of these things. And then you end with checking independence. And that mirrors the Frappy, right? So that shouldn't come as any surprise. There will be 3 FRQs on this one. One FRQ will be a 4-part FRQ, like a normal full-length FRQ. The other 2 FRQs will be 2-part FRQs. So they will each be shorter. So even though it has 3 technical FRQs, it really will be like having 2 FRQs. And I will warn you, simulation comes up, but simulation specifically comes up, and I will tell you this, it comes up on one part of one FRQ, and I will tell you, you are critiquing a simulation method. So you do not have to create one, but you do have to explain the flaws with creating one. And remember, when you explain, you must use words. I'll even say sentences. And always use probability notation. So like probability of a thing occurring, right, equals, and so on and so forth. You have to use that notation. It is super, super, super important in your answers. Okay. I will further tell you that when you critique a method, I will warn you about something. And that is dependence. I would look back over that soft hard candy question, if you remember that one. I believe that was on the homework. The great thing about the soft hard candy question is it forces you to remove for the second round of that candy experiment. You grab a soft candy, and then the next round you have to remove one from the total and remove one from the soft candy pot. I will warn you that your simulation problem hints at a situation that may or may not involve dependence. You will remember that the Frappy simulation problem did not have dependence, right? In the sense that the odds that you completed an assignment, like if one kid completed an assignment, that didn't impact the odds of the next kid completing the assignment, right? If one kid completed an assignment, that told you about the overall probability that kids complete an assignment. But what it didn't do was prevent the next kid from completing an assignment or change the odds of the next kid completing an assignment. Versus sometimes that's the case, like with the soft and hard candy one, the second you take a candy out, that impacts the total. Okay, I've maybe even given away more than I ought to there. So just know that and think about that in theory. That will come up. Okay, I think that's everything I need. Yeah, I think that's everything. Guys, we did it. Okay, keep all of those in mind. We have gone through. We've run through the biggest tips. Know your rules. Know how to apply them. And I will say this for one final, right, for the cheap seats. Remember, okay, this unit, the multiple choice, take a little more time. So prep yourself for that. Know it inside out and backwards. Drill, drill, drill. Believe in yourselves. Do not be afraid. You can do this, okay? And when in doubt, at any point, run a tree or just list the probabilities. You should have seen from responses I've sent you or pictures you've taken in class, various ways in which I have run probabilities and seen the different impacts of those probabilities. You should feel comfortable with those as well and seen the way that my methods work and make sure you're comfortable with them. I am so proud of you. Thank you for being my students. Thank you for loving probability as I do. Or if you do hate it, just know that you will be a master of it. Do not forget it. Do not put it in your brain and then spit it out and forget it forever. Keep it in your mind. Keep these tricks with you and know that you are brilliant. This is Mr. Mays, proud as always, ready and rigorous for us to turn statistics into what it was always meant to be. We are on the map, okay? Watch this video. Rewatch conditional probability. I know it's 54 minutes. Do it while you've got yourself exercising or while you're going on a walk or while you're thinking about life, the universe, and everything, and who invented liquid soap and why. I am proud of you. Thank you for having me as your teacher. This is Mr. Mays signing off.